Hello students, today's tutorial is going to be over graphing absolute value functions. Thank you for joining me. I'm glad you're here. My name is Mr. Nguyen. We're going to be using the rules of transformations to graph these absolute value functions, okay? So let's take a look at this first IXL problem. Here we have y equals absolute value of x. Well, guess what? This is the parent function. So just to remind ourselves that parent function starts at the origin and the slope would be up 1 over 1, up 1 over 1, up 1 over 1. Okay, so I am going to show you how to graph this, right? So your first point is always going to be your vertex. Okay, so you're going to click one time and then you're gonna drag out your mouse and then you're gonna place the graph appropriately according to the slope. Okay, as you can see, it changes when I move my mouse here. Don't click until you're ready to graph. So do the slope. So from here you're gonna go up 1 over 1, up 1 over 1. So there is the graph of the parent function, and that's it. That's as simple as it is. Hit submit and you are ready to go. So don't forget, you know what? Before I move on, I am going to take a screenshot of this function so that we can refer to it when we do other functions. Okay, so I'm going to refer to this graph as the parent function when we do other graphs. Okay, so now I'm going to submit. Okay, very cool. So now we have a different function now. It's the baby function. It comes from the parents. This time we'll have a negative in front, which means the graph is going to be reflecting over the x-axis. So it's going to be, the graph is going to be down here somewhere, right? And then we also have a 2 in front. So the graph is going to be stretched vertically. That means it's going to be pulled apart along the y-axis because the 2 is outside of the absolute value, right? So the graph is actually going to get skinnier. So your slope is actually 2 over rise 2 run 1, rise 2 run 1. Okay, so let's graph the point, the vertex first, and then here's the parent, right? That's the parent right there. Okay, but now we're not graphing the parent. So how do I undo this graph? I just click here and then I think I double click that, or maybe click it once, click it again. How do I undo this graph? Oh, you know what? To undo the graph, I just click at a different location. So undo the graph, and then let's say I click it here, I move it there, right? So if I take the graph, I click on it, I can move it around. So here's the parent. I am going to flip it. So how do I flip it? If I click it here, it's gonna move. So if I click on the one of the legs, I will be able to move it the other way. So here's I'm moving it back to the origin, and now I'm gonna move this right. I'm gonna move it rise 1, run 2. So now if you're here, rise 1, run 2 would be over here. So I make sure I drag my mouse to where that is. So rise 1, run 2, rise 1, run 2, rise 1, run 2. Oh, wait a minute. We're supposed to get skinnier. So it's rise 2, run 1. Oh, so rise 2, run 1. We should end up right here over. Let me click it over here. I better use my mouse. So I'm going to use my mouse here. It's actually better, I think. So rise 2, run 1. I don't know. My mouse too sensitive, though. I need to change the sensitivity on this mouse. So there is our graph. It's actually skinnier, right? So there it is. I just learned something today, too, guys. Glad I'm doing this. Hit submit. There we are. Okay. This one's easy. So let's graph the parent really quick. There's the parent, right? So start at 0 and then run 1 over 1, up 1 over 1, up 1 over 1. And then now we're doing reflections. So we're actually staying the same, but now I'm going to take this point and I'm going to drag it downward. I'm double clicking on the graph and I'm dragging the other way. So going down that way. So it's down 1 over 1, down 1 over 1, down 1 over 1. okay, because it's reflecting. The negative is reflecting. Okay, hit submit. Very cool. Okay, I'm gonna do one more vertical stretch, and then I'll jump level to give us different problems. Okay, so always, what do I always do? I always graph my parent function. There it is. Okay, and then I use the transformation to change it. So the graph here stays at the same origin, but the slope is changing. So the slope is actually 4/1, right? So let me write that down for you. The slope is actually 4. Oh, let me delete my old graph. There you go. The slope is 4, which means it's 4/1. 4/1 means a rise 4, run 1, right? So I'm going to go over here and I'm double clicking on this and I'm going to rise 4, run 1. There's my graph. Rise 4, run 1. Guys, if you are doing this on the computer, it's a lot easier than doing it on your phone. I would not recommend doing these graphs on your phone. So make sure you do it on your school device, okay? Excuse me. And we're ready to submit. Okay, let's jump level. Oh no, let's not jump level because this one is different. This one, it's a combination of a stretch and a translation up. Okay, so again, start with the parent function right there. Okay, start at 0, 0, up 1/1. Now we're gonna double click. Well, before we double click, let's move it up 2. So double click the vertex and move it up 2. Okay, and then now it says what? Uh, the slope is up 2. So rise 2, run 1 because it's 2/1. So rise 2, run 1. Now I double click on this. I'm going to count. Rise 2, 1, 2, run 1. Rise 2, run 1. There's my new graph. Okay. So it's actually pretty easy doing this on IXL. So I mean, if you were to do this on paper, I would probably ask you to do the same thing. Start with the parent function. So you're going to have to make the parent function and then use the parent function to do your transformation to get your new graph. Okay, submit. Very cool. We've seen this one before. This is just taking the parent function right here, and then we're going to move it down 7 units. So I'm going to click on the vertex and move it down 7 units. Done. Submit. Woohoo! Awesome. Okay, this one is different, so I'm going to show you this one as well. Again, we start with the parent function, and then the inside tell us to move left and right, right? Now, remember, left and right is opposite. So if it's +5, you're actually moving to the left. So click on the vertex and move to the left 5 units. And now the +3 tells you to move that vertex up 3 units. So I'm going to take that same vertex and I move it up 3 units. There you go. There is my new location for the graph. Okay, same shape though because the slope is the same. So hit submit. Ta-da! Awesome. I think we've done this one, so I'm going to jump level. Oops, did not jump. Oops, did not jump again. There we go. We've done this one also, so jump one more time. I just like to see, maybe more complex type of problem. All right, this one is complex. This one, notice the 3, it's not outside. The 3 is actually inside, right? So the graph is actually being pulled horizontally, right? So let's see how we do this. Okay, so here is the parent function. Okay, and it says we're moving to the left 3 units. So let's do that. I mean 12 units. Oh, how do we do that? How do we do left 12 units? I don't know if we have enough room to do left 12 units. Oh, you know what? Ah, we actually only move left 4 units. So let me work this one out for you. So if you see the 3, okay, so pretend this was parentheses. So if I have a parenthesis, 3x plus 12 plus 12. I could actually factor the 3 out. So you are in algebra 2. You should remember how to factor this simple one, right? Using undoing the distributive property pretty much. So factor out the 3. And then what you have is x plus 4 inside, right? X plus 4. Because if you think about it, if you multiply this back in, that that 3 times 4 is going to give you 12. So here's the thing about this. Treat this as if it was absolute value. So I could pull that 3 out, and the absolute value of x plus 4 is going to be remain inside. And then that is going to give me a nicer transformation that I could do. So what does this really mean here? This really mean that the slope is now up 3 over 1, and moving to the left really only 4 units and not 12 units, right? So let's try that. Let's try moving to the left 12 units, and then do the slope of up 3. Oh, I'm moving it up. You gotta graph this. You don't graph the vertex, because if you graph the vertex, it's gonna move it up. If you're changing the slope, make sure you're graphing. You're taking the actual points on the legs of the graph to change it, right? So up 3, up 1, 2, 3 over 1. There's my new graph. There's my new graph for this transformation. So let's see if that's correct. Yay, we did it. We did it. Okay, so I hope I'm going to run into that again to really get you to see how that actually works. Okay. All right, let's do this one. So we start with the parent again. All right, so the first one we're going to do is there's a certain order that we have to do this, right? So I'm going to write down the order for you. First thing you want to do is the horizontal translation. So this is moving left or right, right? So this is moving left or moving to the right. Okay, and then the next one is the stretch or compress. Okay, so this is when you do the a value. Okay, this is dilation. This is when you're doing the a value. So this is the a value. I'm gonna put it in there. A value. I'm gonna type it this way so that you a value. Okay, and then you're gonna be so horizontal translation was the k value. This is up and down, right? The k value. Stretch and compress is the a value, and then next we're gonna do the r, which is the reflection. Okay, reflection. This what is responsible for the reflection is the negative sign. The negative sign is responsible for reflection, and then finally we do vertical translation. Okay, and this is gonna be up. Oh, horizontal, left and right. Horizontal was not supposed to be um, K. Horizontal is actually the H value. Sorry about that. I misspoke. This is the H value. It's inside. Vertical translation up and down. This is actually the K value. Okay, this is the K value that we need to worry about. So K value up and down. Okay, so I apologize for that. I just got confused a little bit there. So let's do this. So what are we supposed to be responsible first? We're not moving left and right. So now we have to worry about the stretch first. We are stretching by 5, right? So the slope is actually up 5 over 1. So I am going to change the slope first. Up 5 over 1. Okay. And then the next one I'm supposed to do is the reflection. I do have a reflection, but this reflection actually happened inside the parentheses. So this reflection is actually over the y-axis. If you reflect an absolute value function over the y-axis, it makes no difference. So, I mean, this half is the same as this half. So there is no change, right? Because that negative will turn into a positive anyway because of the absolute value function. That's what it does. It turns everything positive. And then here we have a plus 2, which means I'm taking this graph and I'm moving it at up 2. So there should be my new graph. So let's hit submit and see if we did that correctly. Yay, we did it. We did it. All right, I'm gonna leave this note here because we gotta follow the order here. Okay, so here it is again. Once again, we have all of this mess. So every time you see this, pretend. I guess, for the lack of better word, pretend is parentheses. So this is what you have right here. After you work with the parentheses, then you can start changing it back to absolute value. So I'll show you how that works, okay? So 3x plus 9 in parentheses, and then minus 3 at the end, okay? And then so you go down here and you say, oh, I can factor the 3 out. I can factor that 3 out inside the parentheses, and then I have x plus 3 left on the inside, and then minus 3. And then now I can go and change that back to the absolute value. So y equals 3, and then absolute value of x plus 3, absolute value, and then minus 3. Okay? So now, now we can apply the transformation. Okay? So we're moving left and right first. So well, first of all, do your parent function first. Here's the parent function. Click at there and then click there. So that's the parent function. Now we're going to take this, and because it is plus 3, we have to move to the left 3. So left 3, okay, left 3. And then the next thing is reflection, but we don't, sorry, the next thing is stretch or compress. And we do have a stretch or compress. We are actually stretching by 3, so it's the slope is actually rise 3, run 1. So I'm gonna rise 3, 2, 3, run 1. Okay, rise 3, run 1. Okay, you only have to do it one time. Rise 3, run 1. There's your point. Okay, that's done. And then we move down 3. So take the vertex and move down 1, 2, 3. There is our new graph. Okay, with all of the combinations of transformations that take place. So I am going to hit submit, and hopefully that's correct. Yay, great job, nice job. Okay, let's delete that old problem that we did. Oops, sorry, I didn't mean to delete. There you go. I want to keep this so you guys can refer back to it. Okay, here we have 5 inside, but it's in front, so this is a stretch or compress. We have to do that first, and then we move down. Okay, so let's do the parent function right here. This time we're going to be stretching by 5. So the slope is up 5 over 1. So we're gonna do the slope 1, 2, 3, 4, 5 over 1. Okay, so it's right there. Up 1, 2, 3, 4, 5. Run to the 1. Okay, and then I take that and I move it down 4 units. So 1, 2, 3, 4, and that should be my new absolute value function. Okay, or a graph. Submit. Yay. Okay. Here's another combination of thing inside there. So again, treat this as if it was parentheses. So we do y equals um, parentheses of 3x minus 3 parentheses plus 1. Okay, and then you're going to factor the parentheses out. So you're going to factor a 3 out because they both have a 3 in common. And then what's left inside is going to be x minus 1. Okay, and then plus 1. Now put the absolute value sign back in so that your function actually makes sense. Oops, equal 3, and then absolute value x minus 1, absolute value plus 1. Okay, so now let's see what kind of transformation we have. We have plus 1. That means we're moving to the right 1 unit. The next one we have a 3. So the slope is up 3, run 1. Okay, so you go up to 3 and you run to the right or to the left 1. And then you're gonna, so this plus 1 right here, it translate up 1 unit. Okay, unit. Okay, so these are all combination of transformation in the order that we are supposed to do it. Okay, so remember these orders. Okay, guys. All right, let's do this. So we're gonna click on the origin and then our parent function. So I notice I always start with the parent, and then now I'm gonna do right one. So I'm gonna graph my whole entire vertex and move it to the right 1 unit, and then now the slope is up 3, run 1. So I'm gonna graph the leg of my graph, and I'm gonna do up 3 over 1. Let it go. Now I'm not done yet. I still have to translate up 1 unit. So I graph the vertex again and I move it up. I grab the vertex and I move it up. Okay, so that should be your new graph after all three transformations. Hit submit. Yes, I like doing these, guys. I love transformations. I love, especially, it's so easy to graph on IXL. So I hope you guys enjoy this as much as I do. But all right, let's delete what we did from the previous problem. All right, let's focus on this new one. Okay, again, we're gonna factor. Okay, so we're gonna factor. The reason I'm not skipping anymore and I'm still continuing to do this is because I think you guys need to see these over and over to get really familiar with it, so that when you do it by yourself, you are more confident. Okay, so there is my parenthesis version. So I'm pretending the absolute values are actually parentheses. Why? So that I could actually factor out the 2, right? 2x plus 1. Remember, when you factor out a 2, there's 1 left because 1 times 2 give you 2 back. Okay? And then minus 8. Okay, now I go and I put back the absolute value. So my actual function is y and then absolute value x plus 1, absolute value minus 8. Okay, now I'm ready to list my transformation. So what do I do first? I list the inside first, horizontal. So inside I am adding 1. So remember, inside is opposite, so it's going to the left 1 unit. Okay, transformation, translation, left 1 unit. And then my second is the 2. The 2 will give me the slope of 2, rise 2, or is that's not rise, that's raise. Rise 2, run 1, because it's 2 over 1. And then the minus 8 at the end tells me to move down 8 units. 8 units. Okay, so let's apply this. Let's go back to our mouse cursor and graph our original parent function. And then we're going to graph, we're going to take the whole entire graph by the entire graph by the vertex and move it to the left 1 unit. I need to slow down when I talk. I, I talk too fast. And then I do slope of rise 2, run 1. So I grab this and I do, okay, rise 2. So here's 1. Here's the beginning. So count 1, 2, and then run 1. There's my new graph, but I'm not done yet. I'm supposed to go down a unit. So I go grab the vertex and I move it down to -8. Bam, right there. All right, that's my new graph. Hit submit. Voila. Delete. Awesome. All right, this one is very interesting. This one has all three transformation here. So I don't have to factor anything because there's nothing to factor on the inside. So I can just actually list the transformation. So what is this? -1 on the inside. Remember, you got to do horizontal translation first. So you got to move to the right 1 unit. Okay, so move. I'm going to write the word move right 1 unit. And then the 6, remember we got to do stretch next, right? Stretch next. So the unit is 6, so slope is rise 6 and then run 1. You always have to run, right? Rise 6, run 1. And then the -7 is to move down 7. Okay, move down 7. So let's start with our parent function. and we're gonna go, there it is. And then we're gonna apply this in order, okay? Move to the right 1 unit. So grab the vertex and move it to the right 1 unit. Let it go. Change the slope by 6 and then 1. So grab this and count 1, 2, 3, 4, 5, 6, and then over 1. There's my graph. It's really skinny because it's been pulled, right? A pull along the y-axis. That's why it's skinny. And then we move down 7 units. So take the vertex and move down 7 unit. 1, 2, 3, 4, 5, 6, 7. There's our new graph. Ta-da! Yay! We got 1 point for that problem. Wow, that was exhausting. We got 1 point. Oh well. IXL's being stingy. All right, this one's actually easy also because we don't have to factor anything. So the +3 is going to tell us to move left 3 units. Okay, and guys, I'm writing down these transformations because on your assessments it's going to ask you verbally what the transformation is, right? So you got to be able to say this verbally. Okay, say it verbally. Move left 3 units, and then the 4 tell you to do the slope of rise 4, run 1. Okay, and then the -7 tell you to move down 7 units. Okay, and then now we're ready to graph. Once again, we're going to start with our parent function, and then we're going to do left first, so moving left 3 units. And then the slope, we're going to change the slope to up 4. So 1, 2, 3, 4, and then run 1. And then we're going to move down 7. So we're going to take this vertex and move it down to where -7 is. There you go. Okay, that's our new graph. 1 more point. Oh my God, I have to do 2 more problems. It's okay. I got this. I got this. I love doing this, so I don't mind. Okay, I'm gonna list the transformations real quick, guys. If you think you have enough, you've seen enough, you can actually quit the video and go do your practice. But if you like to stay with me to see more example, I'm gonna work this out all the way to 100. Okay, so what do I'm doing? The +7 first, right? So I'm moving to the left. So move left 7 units. And then, a lot of people would like for you to use the word translate, okay? Because translate is actually an academic word. So we're going to start using translate from now on, okay? But that's what it means. It means moving the graph, okay? So translate left 7 units, 7 units. Now, the next one, the 3, I know I've been writing slope 3, slope rise 3, run 1. But technically, I mean, slope rise 3, run 1 is to help you see what the graph is doing. But the actual terminology for this is actually vertical stretch 3 by 3. By 3, because it's not 3 units, it's multiplying, so that's why it's by 3. Or you can say 3 times. Okay, vertical stretch 3 times. Okay, and then finally I've been saying move up and move down, right? So this is actually translate up 4 units. Okay, so I need to be more careful with using academic language with you guys, but I also want to use student-friendly language to help you understand what the graph is actually doing. Okay, so we're going to start with our parent function. There you go. And we're going to do translate 7 units to the left. So 7 to the left. Okay, I'm going to stop. I'm going to do this one at a time. And then I'm going to do vertical stretch of 3, which means it's going to be pulled 3 times that way. Okay, so up 3 over 1. And then I'm going to translate up 4 units. So I'm going to take the vertex and go 1, 2, 3, 4 up there. Okay, that's my new graph. Submit. Okay, one last problem. This one is easy also. So let's see, what are we doing? We are translate one unit. What are we doing, left or right? We're going to the left actually because we're adding left one unit. Now we're gonna do the slope of 6, right 6, run 1. And again, this is a vertical stretch by 6 times, right? By 6 times. And then we're going to translate down 2 units. Okay? So let's do this. Parent function, moving to the left 1 unit, uh, stretch by 6. So 1, 2, 3, 4, 5, 6. Oh, the graph is really skinny. And then move down 2 units. So graph the vertex and move down 2 units. There is our new graph. Hit submit and 100. Yay! Spectacular. Well, guys, I hope that was very helpful for you. And I hope you guys will have fun when you do this on your own. Let me know if you have any question. You can screenshot your question to me. I enjoy doing this, and I will see you in the next video. Thank you so much for watching. Bye bye.